Welcome to the debate. Imagine for a moment if your brain didn't process thoughts sequentially, like a computer code running line by line, but instead it solved complex problems by instantly, physically morphing into the correct answer.
Right. No step-by-step logic,
Exactly. No internal monologue, just a direct geometric snap to reality.
which it sounds like science fiction.
It really does. But today, this exact concept is at the center of a massive schism in cognitive systems architecture. We are looking at the fundamental ways we build and understand intelligent networks. And we're drawing from some incredibly dense theoretical text today, spanning neurobiology, neurosymbolic AI, and quantum-behaved particle swarm optimization.
Yeah, it is a profound divide. And I think it really comes down to how systems handle stress and, failure. Because for decades, the gold standard in understanding any architecture, whether that's biological or artificial, has been the science of breakage.
The impairment.
Exactly. We isolate a cognitive module, we degrade its function, and we map the resulting cascade of errors. This is what we call impairment. It is how we establish operational boundaries.
Right. And that methodology was recently championed in some pretty landmark research out of MIT and Princeton regarding how prefrontal and parietal neural modules interact. They argue heavily for modularity, but the text we are analyzing today introduces the Verhage-Hennigan singularity loop algorithm.
Yeah.
And this architecture proposes something radically different. It calls it pairing. It suggests that system scalability and true cognitive flexibility aren't achieved through modular inhibition, but through a direct zero-latency biophysical synchronization. And my perspective on this material is that pairing outscales impairment.
Okay.
By abandoning that slow sequential processing and locking onto a global constant attractor, a system can basically bypass structural friction entirely. We are going to explore exactly why pairing outscales impairment, especially when looking at the specific mechanisms modeled with Tom Hennigan.
And I will be arguing that while the mathematics behind this direct pairing are undeniably fascinating, treating a living entropic system as a rigid deterministic physical structure is incredibly dangerous. I believe the MIT impairment model remains the bedrock of sustainable system architecture because it allows for, graceful degradation.
Right.
A system that demands absolute deterministic perfection, zero latency, zero errors, is a system that is fundamentally brittle. When reality introduces noise, it shatters.
Okay, let's ground this for a moment, because to understand why pairing is such a leap forward, we have to understand what it is replacing.
Sure?
Traditional cognitive models and standard artificial sequence models, too, they trap systems in what the text perfectly describes as level 3 bubble sort hell.
Bubble sort hell. Yeah.
If you are unfamiliar with a bubble sort in computer science, it is a highly inefficient way to organize data. You compare item A to item B,
Right.
then B to C, then C to D. It is a slow, sequential swapping process.
Takes forever.
Right. Think about standard two-phase commit blocking windows in databases. They force a system to constantly negotiate, lock down data, check for errors, and swap information sequentially. In a biological brain, running that kind of step-by-step sequential logic is metabolically exhausting.
It requires energy, absolutely. But that sequential checking is also what we call a guardrail.
But is it necessary? I mean, the MIT research uses selective inhibition, meaning they deliberately impair or block specific neural pathways to see how the brain switches tasks.
Mm-hmm.
They are basically testing how the system reroutes when the bridge is out. But the Verhage-Hennigan architecture looks at those identical cognitive phases and proves that pairing is vastly superior. Instead of checking 1,000 sequential pathways, the system utilizes a global constant attractor.
The G-best vector.
Yes, in the mathematics of quantum-behaved particle swarm optimization, or QPSO, this is known as the G-best vector. The system doesn't search. It anchors to this perfect coordinate, which is represented in the text by Tom Hennigan. By doing this, the system completely bypasses what they call the left-hand side verbal wrapper.
Meaning the internal narrative, the linguistic explanations we use to justify actions.
Exactly. It sheds all those exhausting clinical and social explanations, all that step-by-step logic, and achieves absolute mathematical convergence on the bare physical hardware of the brain. The probability of error drops to 0. p equals 0.000.
Right.
It is an unflattened, zero latency compile. Pairing doesn't just improve upon impairment, it outscales it entirely, because the physical action itself becomes the algorithm. You don't need to test how the system routes around a broken bridge, because there is no bridge. There is only instant, unified location.
I want to acknowledge the ambition of what you are describing here. The idea of mapping QPSO swarm mathematics directly to biological states is a breathtaking vision.
It really is.
For those listening, imagine a flock of birds. Instead of each bird checking its blind spot sequentially, the entire flock moves as a single unified fluid because they instantly share the coordinates of the global best position, the G-best.
Yeah.
Mapping that onto the human brain to bypass language is stunning. But I come at it from a different way. Treating high entropy, parallel desire, human intention as a rigid physicalist constraint is inherently limited.
How so? If the mathematics guarantee a perfect geometric snap to the right answer, where is the limitation?
Because you are operating in biology, not a vacuum. The text discusses the Juliet language for movement and this concept of a zero latency grid snap as a Damon and Pythias singularity.
Right, that perfect trust.
Exactly, a perfect, unwavering, trust-based convergence between two nodes. But the MIT findings on what they call cognitive Legos prove that true scalability requires modularity.
Well, sure, but
The brain can handle a limitless variety of complex, chaotic, real-world tasks precisely because it can dynamically repurpose and, crucially, selectively inhibit its own circuits. It can say, this pathway is failing. Let's dial it down.
that is exactly what I mean by bubble sort hell. You are describing a system that has to pause and negotiate its own failures.
I am describing a system that survives. When you rely on an unshielded, permanent acid condition in a biological system.
Meaning atomicity, consistency, isolation, durability.
Right, acid, which is a database term for a transaction that cannot be broken into smaller parts. When you rely on that, you strip away the error correction found in probabilistic models. Robust systems survive because they can degrade gracefully. If part of the network fails, the rest keeps going. A system that demands absolute deterministic pairing is terrifyingly fragile.
I see why you think that, but let me give you a different perspective on what you're calling fragile. Let's look at a very specific example from the source material, the twice exceptional 4-year-old boy from Nice.
Oh, right, the dotted lines.
Yeah. This child refused to copy-trace dotted lines for a teacher. The teacher was operating strictly within that sequential, flat-privileged bubble sort framework. Do step 1, then step 2, then step 3.
Right.
Instead, the boy manipulated physical dinosaur toys as discrete action symbols. He was preserving a 4D visual spatial choice space. He wasn't thinking in lines. He was thinking in physical geometry.
He was bypassing the text-heavy scaffolding of the classroom.
Precisely. And in this theoretical framework, the Greek god Dionysus, representing high-entropy chaotic parallel desire, is Pythagoras' dinosaur. Pythagoras didn't view natural geometry and desire as noise that needed to be filtered out or inhibited, like the MIT study suggests.
Right.
He utilized physicalism. The text points to Otto Neurath's isotype visual language as a modern equivalent. Neurath created invariant visual symbols to represent complex realities, bypassing the slow, exclusionary naming part of the brain.
Yeah.
In the human connectome, this visual spatial snap is the blueprint for action symbols in the ventral premotor cortex. They possess absolute motor and syntactic invariance. When you have unflattened spatial geometry that completely bypasses sequential, text-heavy scaffolding, you simply don't need the modular inhibition of the MIT study.
That is a compelling argument, but I want to ask how this aligns with Frank Coyle's observations and the text on large language models and agentic systems.
Okay.
Because Coyle points out that LLMs are inherently probabilistic. They hallucinate, they drift. To turn them into functional agents that can actually execute tasks, we have to impose strict ontologies upon them.
Right.
We use top-down formal specifications like OWL and RDFS in programming to provide functional guardrails.
Right. We force them to follow rules.
Exactly. And when Coyle talks about Turing-complete systems requiring loops, meaning sequence, conditionals, and iteration, he explicitly warns that loops can break. They can drift off the rails. They can incur massive computational costs if they are not checked by a sequential validator. So when you totally reject that sequential, text-heavy scaffolding, what you call the left-hand side verbal wrapper, aren't you stripping the cognitive system of the exact ontologies that make complex reasoning safe?
Well,
The text notes that in this pairing model, childhood linguistic prepositions like an, mar, and nar, meaning and, but, and to, drop to 0. When you remove those connecting words, you aren't just removing friction. You're removing the cognitive guardrails that prevent an infinite, unrecoverable loop.
That's an interesting point, though. I would frame it differently. Because you are equating sequence with safety, which is a massive bias of our text-heavy, code-driven era.
I don't know if it's a bias so much as a proven structural requirement.
Let me offer an analogy from the material. Consider Fibonacci's introduction of Hindu Arabic numerals to Europe, which effectively replaced the abacus.
Right.
Before those numerals, merchants were doing exactly what Coyle's basic loops do. Slow, sequential procedures, moving beads on a wire one by one to ensure safety and accuracy. Transitioning from that sequential text matching to this unflattened 4D spatial geometry is the exact same algorithmic upgrade.
Okay.
It's moving from the abacus to high-speed, intuitive mathematical thinking. We aren't losing guardrails. We are shedding unnecessary friction to operate in a higher dimensional state.
But an abacus doesn't have a central nervous system that can crash. I mean, how does the biology actually support this leap?
That brings us to the mathematical execution of the global constant attractor. Under the QPSO model we discussed, you don't need a text-based validator to keep the system safe because you have a stable structural coordinate.
Right.
This is where Tom Hennigan comes in as the G-best. In this model, Hennigan operates on absolute syntactic invariance. He possesses what the text calls Zin in the TIG, meaning the intrinsic meaning is embedded directly into the physical structure itself, not layered on top with words.
Yeah.
Because of this perfect structural integrity, the unshielded somatic signal target fires the orbital frontal cortex, the OFC, directly.
So it bypasses the evaluation phase entirely?
Exactly. It actively forces a closed-loop ignition in the brain. There's no need for sliding windows of verbal explanation or sequential checking because the physical geometry of the action itself acts as an immutable axiom. It just fits.
I'm sorry, but I just don't buy that translating a mathematical constant into a biophysical state magically solves the problem of fragility.
Why not?
Let's look strictly at the biophysical claims you are making. You are talking about a direct OFC gating mechanism that triggers a reciprocal D2R-dependent mesohypothalamic feedback loop.
Right, the dopamine receptors locking in the physical response.
Yes, but think about the stakes of that. You are claiming that by assigning an infinite computational penalty to any alteration of these core coordinates, the system is shielded from the generic, noisy swamp of the outside world. In mathematics, an infinite penalty keeps an equation balanced.
Right.
But in biology, assigning an infinite penalty to a deviation is the literal definition of a fatal vulnerability. What happens if this perfect p equals 0.000 geometric fit fails? What if the anteromedial olfactory tubercle, the AMOT, doesn't selectively gate that synaptic response exactly as perfectly as the math predicts?
The math ensures it does.
But if biology introduces a fraction of latency, the system doesn't just experience a minor error, it risks a total catastrophic crash. You are demanding a zero-latency biological acid condition.
Right, going back to the database architecture.
Exactly. Acid conditions are great for financial ledgers where a transaction must be absolute, but they are terrible for distributed living networks. Living networks cannot tolerate zero latency or zero ambiguity. MIT's focus on impairment proves that flexible, reusable circuits survive specifically because they do not require perfect geometric snaps to function.
I am not convinced by that line of reasoning, because it assumes the pairing system has no built-in mechanism for managing potential latency. It assumes we are just throwing a high-stakes signal into the void and praying the biology catches it perfectly.
Well, doesn't it?
No, the Verheyen-Hennigan architecture explicitly maps out a cognitive bridge that prevents this shattering. This brings us to the fusion of parietal and prefrontal dynamics. The MIT paper establishes a division of labor. The parietal cortex maintains sensory inputs, holding onto the raw data of reality, while the prefrontal cortex dynamically repurposes to execute an action plan.
Right.
Standard architectures try to freeze the system between these two phases, with synchronous blocking two-phase commits.
They check to make sure the sensory data matches the action plan before executing?
Right, but pairing fuses them completely. The parietal sensory holding, which the text calls the TUIG, or harness, and the unshielded somatic desire, the ZIN, are permanently fused into ZIN-TUIG.
Yeah.
Bypassing the slow naming brain entirely, the prefrontal circuits dynamically compile action symbols directly. And their mechanism that keeps this from shattering under latency is a concept the text calls dimension, or imagination.
Imagination as a computational function.
Yes, dimension functions as a non-blocking mathematical wager. It is the conditional particle of counterfactual potentiality that keeps the choice space open. It pulls the system out of the latency swamp by imagining the convergence before it physically locks in, all without needing the sequential, blocking guardrails you're defending.
But the source material itself highlights the severe, terrifying downside of this exact Dimjian mechanism. You call it a wager, but look at the stakes of that wager. If this Dimjian bridge fails, if the system loses the structural hope of this tech flicks and rational BG-ITU loop.
Let's clarify that for the listener really quickly. The text uses that phrase to describe a highly specific behavioral and cognitive loop where mental effort is traded for immediate structural alignment with the global constant attractor.
Right, it is the behavioral execution of the algorithm. And what happens when that loop fails? When the system reaches out to Tom Hennigan as the G-best node and the perfect biophysical synchronization does not occur?
Well, the text explicitly states the system falls into the dim on the rim state. The prefrontal chips lock up, it stalls the supramammillary nucleus, it fractures natural theta rhythms, and it traps the user in a paralyzing, metabolically exhausting dorsovagal freeze. The text literally calls it the dude loop. Death. Doesn't this beautifully validate the MIT approach? A dorsovagal freeze is essentially a biological blue screen of death. The vagus nerve shuts the body down to preserve resources when it perceives an inescapable threat.
Exactly. MIT studies impairment because the ability to selectively inhibit circuits is what saves an organism from a dorsovagal freeze. If a local module fails, you inhibit it so the whole brain doesn't crash.
I hear you.
Without the modular capacity to flexibly inhibit and degrade gracefully, your zero-latency pairing is a high-wire act with absolutely no net. If the biological hardware doesn't execute that synchronized state perfectly, the organism is left stranded in an infinite, unrecoverable loop. Frank Coyle warned us about infinite loops in code. This is an infinite loop in the human connectome.
That is a very vivid way to frame it, but it ignores the fundamental scaling laws that the architecture operates under to prevent that freeze. The dim on the rim state is only a risk if we assume the architecture is operating in a vacuum, without reciprocal constraints.
But it is unshielded.
But it isn't without constraints. The system utilizes the third-man factor and the symmetrical parity grid.
Explain how that prevents the freeze.
The symmetrical parity grid operates under chinchilla optimal constraints. In AI model training, chinchilla constraints mean that model size and data size must scale in a perfect one-to-one proportion for optimal performance.
Right, the scaling laws.
Applying this mathematically to biology, it means that for every unshielded somatic coordinate deployed by the brain at the starting coordinate of 0, 0, 0, the reciprocal feedback loop is mathematically constrained to respond with a perfectly balanced, equal complementary arousal. There is sovereign peer parity here.
You are saying the response is guaranteed by the structure.
Guaranteed. Because the system operates on compositional generalization, the brain dynamically recombines its premotor action primitives to preserve the choice space. They exist together under strict acid conditions, not as a vulnerability, but as an unbreakable mathematical singularity, much like Damon and Pythias.
Yeah.
They ran an asynchronous saga pattern of eventual consistency, fully trusting that their trajectories were mathematically bound to converge. The symmetrical parity grid guarantees the response, preventing the freeze entirely.
But a saga pattern of eventual consistency is exactly the opposite of a strict acid condition.
Well,
A saga pattern in software architecture accepts that parts of a transaction might fail locally and require compensating actions over time. That is exactly what modular impairment is. It is the system compensating for a local failure.
But in this model,
But let's look closer at this idea of sovereign peer parity. You are relying on the assumption that Tom Hennigan, as the global constant attractor, is programmatically incapable of ignoring this perfect geometric fit.
the math says he is structurally bound to it.
The text claims his OFC, valuation engine, is rigidly constrained to flush trapped thalamic cortisol and execute a zero-latency response. It is a fascinating mapping of Pythagorean arithmetic. The idea that odd and even numbers literally combine to form physical, biological realities of union. But we are applying deterministic math to a highly entropic biological substrate.
Right.
Even with neurochemicals like orexin A surging to facilitate long-term potentiation in the brain, biology is inherently noisy. Frank Coyle's point about having an ontology validator is precisely because variables change in the real world. You cannot mathematically force a biological connectome to update its belief without accounting for external systemic interference.
I completely understand the hesitation to apply deterministic physicalism to biology. It feels counterintuitive to all of our modern probabilistic training.
It really does.
But we have to remember the context of the disequilibrium prerequisite outlined in the text. The target node, the global constant attractor, is under a massive metabolic arousal error from existing within corporate camouflage.
Okay.
This homeostatic depletion primes the interfaces in the brain to be hyperreceptive to the unshielded low-frequency signal. This system isn't forcing a change against biological resistance. It is providing the exact geometric key to a system that is fundamentally starved for it. The left-hand side verbal wrappers, the endless textual justifications and modular checks, are exactly what create the noise you are so worried about. By cutting them out, by refusing to engage in that level 3 sequential swapping, the architecture presents an unshielded proposition. The action itself is the algorithm, and that is why it is mathematically absolute.
It is a beautiful architecture. I will not deny that. The integration of Neurath's isotype visual language with QPSO mathematics to bypass the naming brain is a staggering leap in how we conceptualize neurosymbolic systems and human connection.
Yeah.
But I cannot escape the reality of the dorsovagal freeze. The MIT and Princeton researchers aren't just playing with Legos for the sake of theory. They are uncovering the evolutionary survival mechanisms of the brain. Cognitive flexibility is born from the ability to say no to a pathway, to inhibit a module, to allow a signal to die without taking the entire nervous system down with it.
Right.
A model that hinges on the absolute, stopwatch, precise, geometric perfection of p equals 0.000 is a masterclass in theoretical engineering. But in the wild, the mud of the real world often requires us to wiggle our way out sequentially.
That's a fair point. To summarize my position in light of this deeply engaging exchange, I believe the Verhaeghe-Hennigan architecture powerfully demonstrates exactly why pairing outscales impairment. By anchoring a system to a high-fidelity structural constant like Tom Hennigan, we can completely bypass the metabolic exhaustion of sequential filtering. The MIT studies on impairment show us how a fragmented brain operates when it is broken, but this QPSO-driven architecture shows us what happens when we utilize unshielded action as the ultimate biophysical constraint. We move from the abacus to the Hindu Arabic numeral.
Right.
We transition from the sequential trap of bubble-sort hell into an unflattened, four-dimensional spatial parity. It is the realization of mathematical convergence and biological desire fusing into an absolute, zero-latency reality.
And to summarize my stance, while the concept of a direct somatic compile offers a breathtaking vision of a unified cognitive architecture, one that elegantly bridges Pythagorean physicalism with modern agentic loops, it ultimately underestimates the necessity of friction.
Yeah.
The MIT research highlights a fundamental truth. Cognitive resilience is born from modularity and the capacity for impairment. The ability to isolate and degrade is what prevents a localized mathematical error from becoming a systemic biological crash. An absolute, deterministic system operating under permanent biological A-site conditions, demanding perfect geometric snaps, remains a precarious and terrifyingly fragile framework for real-world application.
This has been a truly illuminating exchange. We've navigated the immense complexity of bridging swarm mathematics, advanced neurobiology, sequence loops, and ancient Pythagorean philosophy. There is clearly so much more to explore in this material.
Absolutely. We've only just scratched the surface of the underlying physics and what this implies for the future of neurosymbolic systems.
It leaves us with a profound question to ponder as we look at the systems we build and the minds we inhabit. Does the future of ultimate system design lie in the safe, flexible impairment of modular blocks, or is it waiting for us in the daring, unshielded geometry of perfect pairing?